Hello everyone, welcome to our new video on the most asked Python interview questions and answers for fresher and experienced developers. Whether you're preparing for a job interview or simply looking to brush up on your Python knowledge, this video is for you. So if you are ready, let's start today's video. Question 1. What is the difference between list comprehension and generator expression in Python? Answer. List comprehension and generator expressions are both constructs in Python that allow you to create sequences from iterables, but they differ in how they construct and store those sequences. List comprehension. List comprehension returns a list. It constructs the entire list in memory before returning it. It is denoted by square brackets. Here is the example of create a list called squares containing the square of each number in the range from 0 to 9 using list comprehension. Generator expression. Generator expression returns a generator object. It generates values on the fly as they are needed. It is denoted by parentheses. Here is the example of create a list called squares_generator containing the square of each number in the range from 0 to 9 using generator expression. Here's a breakdown of the differences. 1. Memory usage. List comprehension constructs the entire list in memory, which can consume a lot of memory for large sequences. Generator expression, on the other hand, yields values one at a time, using minimal memory. 2. Lazy evaluation. List comprehension evaluates the entire expression and stores the result in memory before returning the list. Generator expression generates values lazily, only when they are requested, which can be more memory efficient. 3. Iterability. Lists comprehensions are iterables. Once constructed, you can iterate over them multiple times. Generator expressions are iterators. Once exhausted, all values have been yielded, they cannot be reused. In summary, use list comprehensions when you need to construct a list and plan to iterate over it multiple times or need random access to its elements. Use generator expressions when you want to conserve memory, especially for large datasets, or when you only need to iterate over the sequence once. Question 2. Explain the GIL or global interpreter lock in Python. Answer. The global interpreter lock or GIL in Python is a mutex that ensures only one thread executes Python bytecode at a time, regardless of the number of cores in a CPU. This means that even in multi-threaded environments, only one thread can execute Python code while others are blocked. The GIL was introduced to simplify memory management and ensure thread safety by preventing conflicts in memory access. However, it can hinder the performance of CPU-bound tasks, as threads must compete for access to the GIL, leading to serialized execution instead of true parallelism. Despite this limitation, the GIL doesn't prevent concurrent execution of I/O-bound tasks or Python functions written in C extensions, as they release the GIL during blocking operations. As a result, Python's concurrency model often relies on asynchronous I/O and multiprocessing to achieve parallelism effectively while working within the constraints of the GIL. Question 3. What are decorators in Python? Answer. In Python, decorators are a powerful tool for dynamically modifying the behavior of functions or methods. They allow you to add functionality to existing code without modifying it. Decorators are defined using the @decorator_name syntax, placed before the function or method definition. Here's a basic example to illustrate how decorators work. In this example, my_decorator is a function that takes another function, func, as its argument. Within my_decorator, there's an inner function called wrapper that adds some behavior before and after calling func. The original say_hello function is then decorated with @my_decorator, which means that say_hello is replaced by the result of calling my_decorator, say_hello. When say_hello is called, it actually invokes wrapper, which adds the additional behavior defined in my_decorator before and after executing the original say_hello function. Decorators are commonly used for tasks such as logging, authorization, performance monitoring, and more. They provide a clean and efficient way to extend the functionality of functions or methods without modifying their code directly. Additionally, decorators can take arguments, allowing for more flexibility in their usage. Question 4. Explain the difference between shallow copy and deep copy in Python. Answer. When working with objects in Python, particularly those containing nested structures, it's crucial to understand the concept of copying. There are two primary methods for creating copies of objects: shallow copy and deep copy. Each offers distinct advantages and considerations depending on the desired outcome. 1. Shallow copy. A shallow copy creates a new object, but instead of copying the elements themselves, it copies references to the original objects. This means that the new object references the same subobjects, or elements, as the original object. Shallow copying is typically sufficient for objects that are immutable or for collections of immutable objects. However, if the original object contains mutable objects, like lists or dictionaries, changes made to these mutable objects in the shallow copy will also be reflected in the original object and vice versa. Shallow copying can be performed using the copy method or the copy module's copy function. Here's a basic example to illustrate how shallow copy works. 2. Deep copy. A deep copy, on the other hand, creates a completely new object with its own copy of the elements. It recursively copies all the subobjects as well, so changes made to the elements in the deep copy will not affect the original object and vice versa. Deep copying is essential when dealing with nested mutable objects, as it ensures that modifications to the copied object do not impact the original. Deep copying can be achieved using the copy.deepCopy function from the copy module. Here's a basic example to illustrate how deep copy works. In summary, while a shallow copy creates a new object but still references the same nested objects as the original, a deep copy creates a completely independent copy of both the outer object and all its nested objects, ensuring that changes in one do not affect the other. Question 5. What is the purpose of __init___ method in Python classes? Answer. The __init___ method in Python classes serves as a constructor. It's called automatically when a new instance of the class is created. The primary purpose of __init__ is to initialize the instance's attributes and perform any other setup that's necessary for the object to function correctly. Here's a basic example to illustrate how __init__ method works. In this example, the __init__ method takes three parameters: self, which refers to the instance itself, and two additional parameters, name and age. Inside __init__ the name and age attributes of the instance, self, are initialized using the values passed to the constructor. The __init__ method is not required in a class definition, but it's commonly used to ensure that instances of the class are properly initialized with the necessary attributes. It helps encapsulate the initialization logic within the class definition itself, making the code cleaner and easier to understand. Additionally, __init__ can also perform other initialization tasks beyond setting attributes, such as opening files, establishing connections, or executing other setup operations required for the object's functionality. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.